Hello everyone, and I welcome you all to today's video. Today we are going to see several approaches to handle missing data values in our dataset, and also we are going to have a quick look at logistic regression. We are going to understand these concepts by solving certain question of end sem question paper. My name is Manas Pathak and I am a student of IIPS DAVV. So let's start. So in the last video, we saw the working of k-means clustering and how an example of k nearest neighbor, the link for which you can find in description of this video. Today, we are going to see the question number 6, how are missing values handled? Suggest three approaches, explain logistic regression and use the logistic function to calculate the probability for a class given input example. Missing values appear when some entries in a data are left blank, marked as NaN, none, or special strings like unknown. If not handled properly, they can reduce accuracy, create bias, and break algorithms that require complete data. Depending on the nature of data and the missingness, several strategies can help maintain the integrity of our analysis. Remove first so the first approach we are going to look here is removing rows with missing data. Removing rows with missing entries is the simplest way to handle missing data. It keeps the dataset clean but may reduce the sample size and introduce bias if missingness is not random. So this is one of the technique to handle missing data, that we remove certain rows or tuples which contain the missing data, so we don't have to account for the missing data while processing the dataset. But it can introduce bias if missingness is not random. By not random, we mean that that certain data values are missing of those rows that have account for particular type of variance for some other feature. So by removing such rows, we are removing that particular category of variance which could be helpful in training the data. We are removing that kind of variance which could introduce bias for that feature, and ultimately it introduces bias in our trained model. We can use drop NA method of pandas in Python to remove such rows. Pros: it is simple, quick, results in a fully complete dataset. Cons: it causes loss of data and possible bias. Imputation methods: mean, median, and mode imputation. This method involves replacing missing values with the mean, median, or mode of the relevant variable. It's a simple approach, but it doesn't account for the relationships between variables. We use fill NA df column dot measure method of pandas in Python to fill missing values of a column. Here df refers to the data frame, column refers to the column in which we have to imputate the mean, median, or mode values, and measure is the statistical measure which could be mean, median, or mode. Its pros are it's easy, fast, suitable for numeric variables, whereas its cons are it may distort the true distribution of the data. Third, interpolation techniques. Interpolation estimates missing values by using the trend or pattern of surrounding data points. It is more informative than simple imputation. So by here interpolation, we can use the we can use the regression techniques. It could be linear regression, multiple linear regression, or even the polynomial regression, depending upon our requirements for the interpolation. So basically the amount of data which we have apart from the missing data, it applies the regression techniques on that data and then estimates the value for the unknown data. We use interpolate method equals to method to fill the missing values using interpolation. In the method parameter, we tell the program that which type of regression method interpolation technique we require to use, or we want the program to use. Its pros are it captures trends, preserves the relationships. Its cons are assumes a pattern, linear, quadratic, maybe complex. Now we are going to have a look at logistic regression. Logistic regression is a supervised learning algorithm used for classification problems. Unlike linear regression, which predicts continuous values, it predicts the probability that an input belongs to a specific class. So logistic regression uses regression to make predictions about make predictions about a class of a tuple. So therefore it is used for classification problems. It is named as logistic regression as so because it uses linear regression as a it has the pre-requirement of logistic regression is linear regression. So the first step in logistic regression would be first finding the linear regression function and then implementing that function in the logistic or the sigmoid function. We are going to have a look at sigmoid function in the next slide. It uses for binary classification where the output can be one of the two possible categories such as yes, no, true, false or 0, 1. So the more popular use of logistic regression is where we have to classify tuples into only two classes, which could be yes, no, true, false or 0, 1. It uses sigmoid function to convert the inputs into probability value between 0 and 1. So as I already told you that linear regression is a prerequisite to logistic regression, because in the linear regression we estimate a function for the given data and then we pass that function to the sigmoid function, which turns it into probability, which provides a probability value for the given function and given data value between 0 and 1. So that is why based on that probability value we classify a particular data point or data tuple. Logistic regression models transforms the linear regression function continuous value output into categorical value output using a sigmoid function which maps any real valued set of independent variables input into a value between 0 and 1. This function is known as logistic function. In the first step, we estimate a continuous function z for a given data using the regression method. Function z can be represented in form z is equals to wx plus b. So as I already told you, the first step for logistic regression would be to estimate a function z for given data using regression method. The function z is represented as w dot x plus b. Here w dot x is the dot product of the weights and the data points x. So w represents all the weights that we have estimated for the given data and x refers to the actual data points. Here b refers to the bias. Now let's understand the sigmoid function. Logistic regression then applies the sigmoid function to z to convert it into a probability between 0 and 1, which can be used to predict the class. So once we have found this continuous function z using linear regression, we pass this function to the logistic function. Now logistic function here or the sigmoid function is given to you here as 1 by 1 upon 1 plus e raised to power minus z or x. Here the power of e, which is minus x or minus, we can say minus z, is the function which we have passed to this continuous function which we have passed to this function, and we have estimated that continuous function using the regression methods. So why we have chosen the sigmoid function here? Because the sigmoid function transforms the for any value of x in the given if we pass any value of x from our data to this function in the continuous function which is represented by minus z in the power of e, then we would get result between 0 and 1, and we can determine that from this graph of sigmoid function. As you can see, the graph touches the y-axis at 0.5 above and you can see for any value of x the graph always stays between 0 and 1. Hence it is a perfect match for estimating probability for a data point to belong to a particular class. So what we do here is we can generally consider a threshold, which is generally the value of threshold is 0.5, but the value of threshold can be greater or lower than 0.5. So based on that value of threshold, we calculate the sigmoid function for each and every data point, and depending upon the value of the threshold value of the sigmoid function calculated for a particular data point, the value being greater than or lower than threshold, we decide that the particular data point belongs to which class. For example, if have decided my threshold would be 0.4 something here, then all the values for data points that for which the sigmoid function has value greater than 0.4 would belong to the class 1, while the others would belong to class 0. So this is how basically the logistic regression works. Now we'll get the more clarity about its working by using an example. So here, for example, I have taken a simple example of logistic regression to predict if a student will pass 1 or fail 0 in an exam based on number of hours they studied. Let us assume that using linear regression, we have estimated function z is equals to mx plus c, where m is equals to 1.5 and c is equals to minus 4. So here basically m is the weight and c is the bias. First, applying the linear equation formula for x is equals to 3. So first we are calculating the value of z for x is equals to 3. So the estimated value for using linear regression for x is equals to 3 is 0.5, as you can see here. Now applying the sigmoid function here, then passing the value 0.5 to the sigmoid function, we'll perform the calculation and we'll get the value 0.622. Now here we are assuming the threshold to be 0.5. Therefore 0.662 being greater than 0.5, we will put the particular value of this data tuple we will put the for value of the x is equals to 3, the we will put it into the class 1, which is pass. So hence the student passes the test. So I hope you understand the logistic regression working from this concept, this video and this explanation. If you have certain doubts, you can drop them in the comment section. I'll see you in next video. Thank you.